Hey viewers, welcome back to our channel. Hope you're doing extremely well. So today we are going to discuss another interesting interview question, which is frequently asked in the interviews. That question of the trees, that is nothing but delete node and return forest. So there might be possibility that you might hear about this question, and there is a fear in your mind about this question. But today, what we are going to do, we will try to understand this question in very easy language, and we will try to solve it. Okay. So without wasting time, let's move on to the question. So what we are provided in this question, at first let's try to figure it out. So I'm saying that in this question we are provided with a binary tree. So let me create one of the binary tree, that is 1 2 3 4 5 6 7 8 9 10 11 13 14 15 16 17 and 19. Okay, so here you can see we are provided the binary tree, and along with the binary tree we are provided with one of the vector or array list. We can see having some of the nodes. So let me write some of the make an array list. Okay, so at first I'm taking it as 5, another I'm taking it as 9, and the last I'm taking it as 15. Okay, so I'm taking these three nodes in my array list or a vector. So what these nodes actually signifies, okay, what these node actually signifies, these node actually tells us that we need to delete all these three nodes, means all those nodes which are present in a vector array list which are provided with us along with this binary tree. We need to delete all these nodes from this binary tree. So means we need to delete this 5 from this binary tree, this 9 from this binary tree, and this 15 from this binary tree. Okay, this is the first task which we need to do in this question. Let's figure out the second task which we need to do. And after deleting this binary tree, after deleting this 5 9 and 15, so let me delete this 5 9 and 15. So after deleting this 5 9 and 15, our tree will be look like this. This 9 will be removed from something from here, 15, and this 15 will be removed something from here. Okay, and after deleting our these nodes, our tree will look like this. What we need to do is this. Here you can see that this actually is nothing but one of the binary. This is one of the binary. This is the another binary. This is one of the binary, and this is one of the binary. Why these are the binary? Just because we have deleted some nodes, and after deleting the nodes, this becomes the different binary. Okay, what we need to do, we in this question we need to create a new array list or a vector, and we need to store these binaries root. Okay, we need to store these binary roots. Here you can see the root of this binary, this particular binary is nothing but this 16. The root of this binary is nothing but the root node, that is the 1. Similarly, for this binary the root is 10, and for this binary the root is 11. So what we need to do, we need to store them in some of the data set, and we need to return it. So this is what we need to done in this question. So I hope you get the understanding of this question. If you don't get it, please watch it again. And if you got the question problem statement of this question, then it's my request, please pause this video right now and try to solve it by yourself. And obviously we are discussing the solution after all. So uh, let me recreate it. Yeah, it was 15. Okay, now let's try to understand the discussion approach. Okay, so the first thing is that we need to delete some nodes of the binary tree, and we already know how to delete it, but here we need to perform one more task along with the deletion, that is nothing but storing the roots of the children's. Okay, so you might be thinking that in which order we need to iterate over the binary tree, whether we need to do it in the in order or pre-order or the post order. Okay, so let's try to figure it out. Okay, so what I'm going to do at first is I'm going to store this data in a set, in a hash set, or there is another data structure for the C++ programmers. Okay, so I'm going to store it in a set. Why I'm going to store it in a set? Uh, just because in a hash set, okay, in a hash set we can access any of the element in order of one time complexity. I don't want to spend any of the time in accessing any of this data structure. Okay, that's why I'm going to use a set. I'll just store these values into this set. So now try to iterate over the binary tree. Okay, I don't know which iteration I'm doing, which traversal I'm doing. I'm just going to iterate over the binary tree. Okay, So at first I get this 1. Now what I will do, I will check whether this 1 is actually present in this set which I have created right now or not. Here I come to know that this 1 is not present. What I'll do, I'll move forward. I will reach this I will reach to this 2. Again I will ask whether this 2 is present in a set or not. Here you can see that this 2 is not present. Let's move forward. We reach to this 4. Whether this 4 is actually present in our set or not. No, this 4 is also not present. Let's move forward. We reach to this 8. We ask the same question. We get the answer no. But the moment we reach to this 9, here we come to know that yes, this 9 is actually present in a binary. In the set that we have created. Okay. Now, what was my first task? Actually the first task was of the deletion of the node. So can do I need to delete it right now? Can I delete it right now? You might be thinking that yes, it is yes, as it is required to delete the node in a question, so why not to delete it? But I'll say that I'm not going to delete it right now. I will delete it during the backtracking or the a little bit later. Okay, why? Why I will do it little bit later? Let's try to figure it out. Yeah, here I come to know that I need to delete this 9, but I am going to store this information in any of the variable, or I'm going to store this information in my mind. Okay, let's move forward. I reach to this 16. I come to know that I don't need to delete this 16. Similarly, no need to delete this 17, and similarly no need to delete this 19. The moment we start backtracking, we reach to this 17, we reach to this 16, we reach to the 9. Okay, here I come to the 9 again. Okay, and as per our requirement, we need to delete this 9. Now can I say that I can easily delete this 9? Means there is no such stress or pressure on this 9 that whether is there any future node or whether is there any children node of the 9 which actually need to get deleted but which will not be deleted due to the deletion of this 9. There may possibility you are not getting it. Okay, let me try to explain it in a simple word. Okay, when we delete it in a pre-order, okay, means the moment I get this 9 at the first attempt, the moment if I will delete it, there may possibility that I will lose the future information. Okay, I will lose the remaining information which is actually attached to this 9. Okay, if I delete this, if I delete this link will get break. Okay, and the possibility of accessing the 16 will become less. Either I need to save it somewhere else, or either I need to do something else. Okay, so if I try to solve this 16, try to store this 16 in some any of the other data structure, then definitely my work will get increased and it will become more hectic. Okay, it will become more hectic. But now what I'm going to do is that I'm making an assumption that yeah, I get a node, I encounter a node which I need to delete, but I'm going to explore its children's at first, and the moment I start backtracking, I will delete it in a post order. So here you can see that in this question we are going to work in a post order. Why we are going to work in a post order? Because if we delete a node in a pre-order, if we work in this question in a pre-order and if we delete it, there may be possibility our work will get increased out, or we need to do some more work to handle the children's of that deleted node. Okay, so I'm assuming that we will work in a post order, means the moment we start backtracking, we will delete it, because in this moment I have a faith or I can trust only this 9 that its children's, if any of its children's which need to get deleted is already deleted up and there is an updated 9. Okay, means its children is already updated. I can easily update this 9. So what I'll do, I will delete this 9 now. So yeah, this 9 will get easily deleted without any stress. Now let's again backtrack. We reach to this 2. Now moving forward, I make a call to this 5 where I will ask the same question whether I need to delete this 5 or not. Yeah, I need to delete this 5. Okay, so can I delete it right now? No, if I delete it, this 5 node right now, the information of 10 and 11 will get lost. Okay, the information of 10 and 11 will get lost, and then with possibility I need to store it somewhere else to make a traversal on them. But I don't want to increase my work, so what I'll do, I will delete a node in a post order. So uh, let explore its children. I reach to this turn, I will ask the same question for it, and here I come to know that no need to delete this turn. Moving the 11, no need to delete this 11. Let's backtrack. Reach to this 5. Okay, now during the backtracking time, what we'll do, we just delete that particular node, and here I'm going to delete it, and we deleted successfully. Now again let's backtrack. We reach to this one, Now make a call to this 3. We reach to this 3. Again asking the same question to the 6. No need to delete 6, 12, 13, 7, 14 and 15. We reach to this 15. Okay, now here we need to delete this 15. Do I need to ask, do I need to move forward? Just because this is a last node, this is a children node, means it don't have any of the children, it don't have any of the node which I need to explore. Okay, so what I'll do, the moment I encounter it, or the moment, as there is no such backtracking, so I can delete it easily. Okay, so I just delete it. Now you can see that here I have some of the binary. This is one of the binary, this is one of the binary, this is one of the binary, this is also one of the binary. Okay, this is one of the binary. So according to my question, what I need to do, I just need to return their root children. So the root of this binary, that is nothing but 1. The root of this binary, that is nothing but 10. The root of this is 11, and the root of this is 16. I just need to return this data. I hope you get the understanding part of this question. So now what we are going to do, we are going to move on to the Pepcoding portal, and now we are going to write the code there. So this is the Pepcoding portal, and what we need to do here is this. We need to complete this function. Okay, so there are two parameters, that is the root node and an array of the integer which contains the values of the nodes which we need to delete. So let me work as per my requirement. The requirement is the hash set. The hash set of integer. Set equals to new hash set. Now what I'll do, let me put all the value of the map into set. Okay, now let me create an array list. I'm not creating the array list, actually I'm expecting that my function which I'll create right now will return me the array list tree node, and I'll store it as answer. Okay, so I'm just going to create a new array list. My function will not return anything. Okay, helper, and there I will pass some parameters to this helper function, that is the root node, the set which contains all the elements, and the answer. Okay, and lastly we will return this answer. So let me complete this function. That is a public static int, not the int, actually void. Okay, tree node, actually why the tree node, we figure it out soon. Okay, so helper in tree node root and has set of integer tab, naming the set, and array list of integer answer. Why I have taken the helper function of a tree node return is because I need to return something, means the moment I will delete any of the node, I just need to return null to update the link. So that means I want to return something, and even if I don't delete the nodes, I just need to maintain those nodes. Okay, that's why. So what I'll do, if root is null, that is the base condition. If we encounter the null in our root action, if this is null, I just do nothing, return null. Okay, now what I'll do, I'll make a left and the right go. Root dot left, root dot right to the helper function. Root left, set, and answer with the same parameter. Similarly here, helper root right, root right, set, and answer. set an answer, parameters. Okay, now let's figure out. Now let's try to work only on those nodes which we need to delete it. Okay, so if set dot contains uh, root dot var, if set dot contains this value, what I'll do, I need to check whether it left child exists or not. Root dot left is not equals to null, and similarly if root dot right not equals to null. I'm checking both of these things because if such a thing happen, I just need to add it left and the right children. Answer dot add root dot left and answer dot add root dot right. Root dot right. Okay, so if such a case arises, I just need to return just because I need to break the link. So that's why I'm returning null. Otherwise, I just need to return the same node on which I am working. And here, before returning answer, I just need to check one more thing. What was that? The condition for the checking whether the root node the condition of checking of adding the root node into my answer array means if set dot contains root dot val. So if not, so what I need to do, I just need to add the answer also. The answer dot add root. So that's all for the code. Let's try to run it. And here we are getting some error, that is array list answer means, I think, yeah, there is some error while creating the answer array list. Is there any other error? Yeah, there is one more error, that is answer dot add root dot left and tree cannot be converted integer. Okay, let's figure it out. Why are we getting this error? We have created array list of the type int. Here we need to mention the tree node. Okay, now let's again run it, and yeah, here we are getting the expected output. Okay, so means our code is accepted, and that's all for this video. I hope you get the solution of this video, the concept of this video. If you like this video, hit the like button, share it with your friends, and subscribe to our YouTube channel. Till then, stay safe, stay healthy. Let's meet in the next video.